Today we're going to be talking about pH scale calculations. Now, acid and bases form hydronium H plus ions and hydroxide OH minus ions. Now, acids form our hydronium ions H plus, so if a compound's going to be an acid, they're going to start with hydrogen. And bases form hydroxide ions, so OH minus. And if a compound is a base, it's going to end in OH minus. Now, acid-base solutions consist of both ions, though. So, acids are going to have more hydronium concentration ions than hydroxide, and bases are going to have more hydroxide concentration ions than hydronium. Now, these brackets are indicating concentration. So, whenever you see brackets, we're talking about concentration. Now, since all acid-base solutions contain both ions, there is an ionization constant of water, which is Kw. So that leads us to an equation of Kw equals the concentration of hydronium times the concentration of hydroxide equals 1.0 times 10 to the negative 14. Now, pH value measures how acidic a solution is, so essentially the potential of hydrogen. P represents potential, H is hydrogen, pH. So for an acid, our pH is going to be less than 7. Bases, our pH is going to be greater than 7. And for a neutral solution, pH is going to be equal to 7. And pH indicates the concentration of hydronium ions, so H+. So there's two equations we would be using. pH equals negative log of concentration of hydronium, or concentration of hydronium equals 10 to the negative pH. Now, pOH value measures how basic a solution is, so potential of hydroxide. P is potential, hydroxide is OH, so pOH. So acids, our pOH is going to be greater than 7, and for bases, our pOH is going to be less than 7. And pOH indicates the concentration of hydroxide ions. So two equations is we have pOH equals a negative log of concentration of hydroxide, or the concentration of hydroxide equals 10 to the negative pOH. And since all acid-base solutions contain both ions, the pH and pOH sums up to 14. So 14 equals pH plus pOH. I know that's all a whole bunch of a lot of equations and stuff like that, so when we do pH scale calculations, we're going to be using this triangle. This triangle, we can treat it as a mole island map. It kind of tells, we figure out where we're starting with and what we're going to, and it'll tell you what equation you're going to be using. Alright, so let's go ahead and do some practice problems of the pH scale calculation. So problem number 1 says, if a solution has a hydronium ion concentration of 1 times 10 to the negative 11, there's an error on this problem. We just have to make sure we put the unit for concentration, which is molarity. We're going to calculate the hydroxide concentration, pH, and pOH of the solution and determine if it's an acid or a base. So we are given that concentration of hydronium, and we need to solve for concentration of hydroxide, pH, pOH, and we need to determine if it's an acid or a base. Since we are starting with hydronium ion concentration, we are going to start at this corner of our triangle. So I can either go, following this triangle arrow, there's many different ways you can go. For this one, we can either go to the right and solve for our hydroxide, or I can go down and solve for pH. And no matter if you're going to go clockwise or counterclockwise, just make sure you go around and complete that square to make sure you solve all the parts that we need to solve for this problem. So for this problem, I'm actually going to go to hydroxide first. In the first equation we are going to use, according to our square, is we're going to use 1 times 10 to the negative 14 equals H plus concentration times our OH minus concentration. So let's go and plug in what we know. We know from our problem what H plus is. And to undo a multiplication, since OH minus is being multiplied, we divide it to both sides.
And do you see how both of these numbers, the 1 times 10 to the negative 4 and 1 times 10 to the negative 1, both are 1 times 10? Because they're both 1 times 10, the easiest way we can solve this without really plugging into the calculator is we are actually just going to subtract those exponents. So we are actually going to do negative 14 minus negative 1. We know a negative and a negative becomes a positive, so negative 14 plus 1 equals negative 13. That number is going to be our new exponent. So the concentration of hydroxide equals, we still need to write the 1 times 10, but the new exponent is the negative 13, and the unit for concentration always is molarity. So that's going to be the answer for our OH minus. So we solve for that, so we're good. So now continuing on with our triangle, moving on to our next part, we just got to here. So now we're going to move down, just continuing around, and now we're going to solve for POH. And the equation that's on that down arrow says that POH equals the negative log of OH minus. So let's go ahead and plug in what we know. We just solved for OH minus previously, so we're going to plug that number in. 1 times 10 to the negative 13. And this answer, so the log of this, because it's 1 times 10, the log is actually going to just be the exponent. So this is POH equals negative 13. But we just said a negative equals a positive, so POH is 13. So we solve for the POH. And again, continuing around our circle, so now we just got to POH, so now we finally have to go to pH. And the equation that arrow tells me we need to do is pH plus the POH equals 14. So plug in what we know the POH is 13. Subtract 13 to both sides. And our pH equals 1. So that's our pH. And the last thing that we need to do is determine if this is going to be an acid or a base. And we look at our pH value. We know for an acid, our pH needs to be less than 7, and for a base, it needs to be greater than 7. Well, our pH is 1. That is less than 7, so this indicates an acid. And that is how you do problem number 1. So these types of problems, you need to give me 4 answers, so you're going to have 4 circles. So let's go ahead and do problem number 2. It says if a solution has a POH of 8, we're going to calculate the H plus, OH minus, and pH of the solution and determine if it's an acid or base. So this time we are given our POH of 8. So we are going to start at the POH corner of our triangle. And we need to solve for H plus, OH minus, and pH and determine if it's an acid or a base. So looking at our triangle, I can either start by going up or to the left. It does not matter which direction you do. What I am going to do though for this problem is we're going to go up first. So if we go up, our first equation that our square tells us is that OH minus equals 10 to the negative POH. So let's go ahead and plug in what we know. Our problem gives us our POH, so it's 10 to the negative 8. But hey, we don't need to plug this into the calculator. When you do plug in 10 to the negative 8, it's actually just going to give you 1 times, it's going to give us 1 times 10 to the negative 8. All you got to do is add that 1 times before the 10, and this is concentration, so the unit is molarity. And that is our OH. And moving on, around our circle, we just got to OH minus. Now we got to go to the left, completing that square. And the equation that it gives us is that 1 times 10 to the negative 14 equals, sorry, that doesn't look like a 4, H plus concentration times the OH minus concentration. So it's going to plug in what we know. We just solved for OH minus. So let's plug that in. 1 times 10 to the negative 8. And to undo a multiplication, we divide the both sides. And all we got to do, since they're both 1 times 10, we just subtract the exponents. So negative 14 minus negative 8. We know a negative becomes a positive. So this becomes negative 6, which is the new exponent. So our H plus concentration is, we still have to write that 1 times 10, but the negative 6 is our new exponent, and it's concentration, so we need to make sure we provide our unit. And that is our H plus. And then, again, still going on our triangle, we just got to H plus now. Now we're going to move down, and the equation we're going to be using is pH equals negative log of H plus. So let's go ahead and plug in what we know of 1 times 10 to the negative 6. And the log of any number that's 1 times 10 is automatically the exponent. So our pH equals the negative 6, because we still have to bring down that negative sign. Negative and negative becomes a positive, so really our pH equals 6. And then lastly, we got to figure out if it's going to be an acid or a base. Our pH is less than 7. Less than 7 is an acid, so this solution is going to be an acid. And that is how you do problem number 2.
So go ahead and do problem 3 on your own. Pause the video, and when you have your answer, press play. And here's your answer. And then go ahead and do problem number 4. Pause the video, and when you have your answer, press play. And here's your answer. And that's it. Thanks, guys.